Okay, in this video we're going to continue exploring complex number math. So how do we divide? That's where we're at. We know how to add, subtract, multiply. Now we need to figure out how to divide complex numbers. It's two-step. First, we need to figure out what the conjugate is. Figure out the conjugate. And then FOIL. Usually FOIL or multiply. Okay, so let's do an example here. Take you through the process. Okay, we have 8 divided by this complex number here, 1 plus I. First, we need to figure out the conjugate. Remember, a conjugate is basically the same thing as this, except we change the sign. So the same values, but we change the sign to the opposite of whatever it is. We have to multiply the bottom and the top. Anything you do to the denominator, you got to do to the numerator. Okay, and then we can simplify this. All right. So that's really the process. Let's talk about why we're doing this. In order to divide conjugates, one thing we can never have in the denominator position is I, or an imaginary number. So the only way to get rid of I, we kind of talked about this in our last video here, if we can square I, we can get it equal to a real number. And we get rid of that imaginary number there. So the conjugate allows us to do that. It allows us to multiply our i's and to get rid of them, much like if we have a fraction with a radical in the denominator position. If we multiply top and bottom by the radical, so this is called rationalizing, much like how we rationalize to get rid of that square root, because squaring a square root gets rid of it. We do the same sort of process to I. So we're squaring I to get rid of the imaginary part of it and to create a real number out of it. So let's do the math now. Top is just distribution. 8 times 1, that's 8, and then 8 times negative I, it's negative 8I. We get in the denominator position. Here we have to FOIL because we have two binomials here. So 1 times 1 is 1. 1 times negative I is negative 1I. Writing the coefficients might help you keep things straight here because i's and 1's kind of look similar. Inside, I times 1 is positive 1I. And then I times negative I is negative I squared. So that's all the denominator right there. Let's rewrite negative I squared. Well, let's rewrite I squared as negative 1. And so we have the opposite of negative 1. This negative is still there. So that becomes a positive 1, right? So we got a positive 1 in the front. Now we have a positive 1 in the back. What happened to our middle terms? They canceled. That's what we wanted. We wanted to get rid of the I, and we did. And so what's left is, really what's left is the product of the first terms plus the product of the last terms. We can use that shortcut. And rather than have to FOIL it out, we know that the middle terms are always going to cancel if we're multiplying conjugates. And we're just going to be left with whatever the product of the first terms is, added to whatever the product of the last terms is. So 1 plus 1 is our denominator, so that's 2. And up top we still have 8 minus 8i. So really we have two fractions here. We have 8 over 2, and we have negative 8i over 2. So let's simplify these fractions, and then we'll be able to write it in our standard form. So 8 divided by 2 simplifies to 4. There's our real number in front. And negative 8 divided by 2 is negative 4, and the I is there. And there's our complex number in standard form. So we divided complex numbers. It's probably one of the most complex things we've done so far. So let's do another one. Get rid of this. Do another example. 3 plus I divided by 3 minus I. So in order to divide complex numbers, we need to multiply top and bottom by the conjugate of the denominator here. So we got 3 plus I is the conjugate. And we do the same thing to the top, multiply top and bottom by the same thing. We're going to have to FOIL top and bottom. On top we have 3 times 3, that's 9. 3 times I is positive 3I. Same thing there. And then we have I times I, so we get a positive I squared. We'll simplify that. Okay, there's the top. Let's simplify the bottom here. Remember our shortcut, since we're multiplying conjugates, we get the product of the first terms plus the product of the second terms. We'll get a positive 1 out of that, and if you don't believe me, let's do it. 9, 3 times 3. Multiply outside, we get 3i. Inside, negative 3i. And then last terms. Alright, well the middle terms cancel, they're opposites. I squared is negative 1, and it's the opposite of that. So we get 9 plus the opposite of negative 1, 9 plus 1. And that's what we said in our shortcut. Alright, so let's simplify the top. The denominator ended up being 9 plus 1, that's 10. So let's simplify the top. I squared, well, let's cross that out and write negative 1 instead. So now let's combine our like terms, our real numbers. 9 and negative 1 give us 8. And 3i plus 3i give us 6i. Simplify, we got two different fractions, right? 8 over 10 plus 6i over 10. So let's simplify. This reduces down to 4 over 5. We're adding 6 over 10, which reduces down to 3 over 5. And I is on the end there. Even though these have like denominators, they're not like terms. This is an imaginary number, and we can't add it to our real number in front. So we got to keep it in this form, the standard form. Real number in front, imaginary number last. All right, let's do one more, maybe two more. See how fast we go here. Let's try negative 5 minus 3i divided by 4i. So here's one that may seem tricky at the beginning. If we're going to try and find the conjugate of this, really what is happening is this is 0, that's our real number that's in front, plus 4i. There's the complex number, and sometimes they won't write the 0 in front because really it doesn't make a difference. So what was the conjugate of that would just be 0 minus 4i, and we don't have to use that 0 either. So it's just always the opposite of this, of whatever this is, basically, right? That's the simpler way of thinking about it. Alright, so up top, we're going to have to distribute this to everything right here. So negative 4i times negative 5 is positive 20i. We should have wrote that last, but that's okay. And then negative 3i times negative 4i, that's positive 12i squared. Negative 3 times negative 4 is positive 12, and then I times I is I squared. And that is over whatever the product of these are. That's negative 16, that's 4 times negative 4, and then I times I will give us another I squared. Let's try and simplify this mess right here. I squared is really negative 1, right? So it's 12 times negative 1. That's negative 12. got that 20i in front still. And on the bottom again, I squared, that's negative 1. So negative 16 times negative 1 is positive 16. Alright, let's break this up into two fractions, write it into our standard form here. Let's see, we got negative 12 over 16 is our whole number. And then we're going to have a positive 20i over 16. Let's simplify that. Let's see here. Negative 12 over 16 gets reduced to negative 3 over 4. And 20 over 16 gets reduced to 5 over 4. And this I gets written last. There's our standard form. Can't add these two things together. This is a real number right here. This is an imaginary number. So this is our final answer. I think we got time for one more. Let's try and do one. It's a bit of a challenge here. Square root of 10 divided by the square root of 10 minus I. Alright, first figure out the conjugate. The conjugate would be the same thing, opposite sign. Multiply top and bottom by the same thing. We're going to distribute the top. The square root of 10 times the square root of 10. Well, that's the square root of 10 squared. So that undoes the radical and we're left with what's underneath 10. And then the square root of 10 times I gives us positive square root of 10i. Well, really the I is written in front, which is weird. Let's FOIL the bottom. The square root of 10 times the square root of 10, that's 10 again. We could do our trick here with the last term, so negative I times I gives us negative I squared. We don't have to worry about those middle terms. So really that's 10 plus 1, right? It's double negative. So on the bottom we got 11. 10 plus 1. On top we got 10 plus I times the square root of 10. I guess the I is going to get moved anyways. Let's see what happens there. The real number first. 10 over 11. Plus square root of 10 over 11, and I written last. There's our standard form. So maybe it looked a little more complicated than it actually was. Just FOIL, simplify. Trickiest part maybe even just coming up with that conjugate. But yeah, there's dividing complex numbers. It's the most complex of the complex number math. But it's not too bad.